Welcome back to All This Math. This is Professor Parker, and today we're going to talk about some calculus. So today we're getting into some calculus. Now, this is actually going to be the first calculus video that I will have ever posted on the All This Math YouTube channel. So welcome. And I hope that this is the first of many calculus videos, as I'm currently doing like a heavy, intensive review of calculus. I haven't really studied calculus in a long time. I taught calculus one time in my teaching career back in like 2011. So it's been a minute, but I'm glad to be able to bring some calculus content to you. So today, what we're going to do specifically within the realm of calculus is we're going to find the first derivative. All right. We're going to find the first derivative of the function that you see behind me. All right. So the function that you see behind me is f of x is equal to x to the third power minus 3x squared plus 1. Now, there are derivative rules that we can use in order to find the derivative of any function. So what we'll do is, first I'm going to rewrite it in derivative notation. So this is function notation, f of x. But if I want to represent the derivative, what I'm going to do is I'm going to use like a little like tick mark or like an apostrophe mark, right? So that's going to look like this, f prime of x. F prime of x. See that little 1? It looked like a 1, but it's not really a 1, right? But it just kind of looks like that. It's more like an apostrophe type of symbol, right? So what that's equal to is there's another symbol that we use, which is ddx. So ddx is written like this. The derivative of d with respect to x, or the derivative with respect to x, is what that means, this symbol right here. And what we're actually going to do is we're going to take the derivative of each of these three terms. So we're going to take the derivative of each of those three terms. So the way I'm going to set this up is like this. I'm going to have ddx of x to the third. I think I need a better marker. So hopefully this joint works better. Minus, bring my minus on. And then I got ddx of 3x squared. Then I bring my plus sign down from right here. And I got ddx of 1. Now at this point, we have the problem set up. We need to understand what the derivative rules are so that we can take the derivative of each of these three terms. So there's one rule that's going to be used for this, which is the power rule. What I like to call the black power rule, right? So I got my man Kwame Ture right up here on the wall with me, right? So the black power rule, it says you take the exponent and you throw it out in front of the term so it gets multiplied by the pre-existing coefficient. So it's kind of like this. There's an invisible 1 in front of this x to the third because it's 1x to the third. X to the third and 1x to the third are the same thing. You already know that probably if you're at the calculus level by now. So you do 3 times 1, which is 3, and then you subtract 1 from whatever the exponent used to be. So my exponent was 3. So I'm going to subtract 1 from 3. That's going to give me 2. So it's two things I got to do for this part. I got to swing this 3 in front of the x. And basically that's doing 3 times 1. 3 times 1 is 3. So I'm going to have 3x squared. Now, what we need to understand is, where did this 3 come from? Again, I took this exponent and I swing it in front of the x. That's how I take the derivative of this term. I take this 3, swing it in front of the x. Now, if there was already a coefficient written there that was not a 1, I would still multiply by that. So because there's an invisible 1 here, I basically multiply 3 times 1. And that just gives me 3. But if there was a 5 right here, then I would have had to do 3 times 5, which would have gave me 15, right? So you're not just arbitrarily, randomly just putting the exponent in front of the variable. You're actually multiplying the exponent by the existing coefficient. And whatever the coefficient is, whether it's a 1, a 5, a negative 2/3, whatever it is, you multiply that exponent by the existing coefficient. Then the second thing you do is you got to subtract 1 from the exponent, subtract 1 from the exponent, and then that's going to give you your new exponent. So that's how I got 3x to the second power, right? Now for this term, 3x squared, I kind of do this, right? So there's a constant rule, right? where, not really a constant rule, there's another term for it that escapes me right now. It's like the a coefficient rule. I forget, certain textbooks call it certain things or different things. But at any rate, what it really happens is, same thing, similar to how we did in the x to the third term. You're going to take this 2, swing it around, multiply it by the 3. That's going to become 6. Now, the minus sign was already there, so I bring that down. 2 times 3 becomes 6. And I write the x. Now, what's 2 minus 1? 2 minus 1 is 1. So now I'm just left with x to the first power. But as we know, if your exponent is 1, you don't need to write it. So we just have minus 6x. Now, right here, this is the constant rule. The constant rule says that anytime you take the derivative of a constant, because really what we're saying is like, okay, what's the slope of the tangent line of that term? So if the tangent line was y equals 1, remember from algebra that when you got y equal to a number, that is a horizontal line. That represents a horizontal line. Just like if you had x equals a number, that represents a vertical line. So since the derivative, and this kind of gets into the theory of calculus and the background information, but the derivative is the slope of the tangent line. The slope of the tangent line to a curve at a given point, right? I'll do another video to get more deeper into that, but the slope of the tangent line to a curve at a given point. So that's why it should make sense that the derivative of a constant would be 0, because we're really wondering, okay, so what would the slope of this line be if it was y equals 1? If it's y equals 1, it's a horizontal line. And you should remember and memorize the fact, if you don't already, that all horizontal lines have a slope of 0. All right. So that's going to be like basically saying plus 0. So now I'm basically done, except I just need to simplify this because I don't need to write plus 0. I just wrote it there just to show, what's actually happening step by step. So I'm going to simplify this, and I'm going to have 3x squared minus 6x. So I got f prime of x is equal to 3x squared minus 6x. And that's about it. That's how you find the derivative of a function, using a couple different rules. It's different rules to this, and we used a couple of them. We used the power rule, and we used the constant rule, right? And that's really about it. So again, if you have not, I forgot to mention this in the beginning of the video. If you have not already, please subscribe to the channel. Please hit the notification button so you'll be notified whenever I release new content. And also share this video with some other people. Tell people, go through the page, look at the other videos, find out something that you're interested in, find out some things that you saw in class and you don't fully understand, and let somebody know. All right. And as always, do remember that there's all this math all around you. Peace.